Hello students, this is Manoj. Let us start our first session in electrochemistry. In this session, we will discuss about some of the basic concepts like electronic conduction, electrolytic conduction, resistance, conductance, specific conductance, and cell constant. So let us begin. What is electrochemistry? Well, we can say that electrochemistry is the study of the production of electricity during a spontaneous chemical reaction and usage of electricity to bring about non-spontaneous chemical changes. Or in a very simple terms, we can say it is the study of conversion of electrical energy into chemical energy and the usage of electricity to bring about the chemical changes. And in this topic electrochemistry, we'll study about the electrical properties of the solutions, particularly electrolytes, and we'll look into the various application of it. Well, we know that electrical energy is carried through the matter in the form of electrical current. Based on the ability to carry electricity, we can classify the substance as conductors, semiconductors, and insulator. Now, what are conductors? Conductors are the substance which allow electric current to flow through them. Examples are metals, aqueous solutions of acids, bases, and salts. Even impure water is capable of conducting. Conductors can be classified into two types. They are metallic conductors, and the second type is electrolytic conductors. In metallic conductors, since electrons are responsible for carrying electricity, they are also known as electronic conduction or electronic conductors. Now let us discuss about the difference between the electronic and electrolytic conduction. Electronic conduction means the flow of electricity through metal, whereas electrolytic conduction means flow of electricity through a solution or an electrolyte. In the case of metallic conduction, the flow of electricity takes place without decomposition of the substance. If you repeatedly pass electricity through, say for example copper wire, we know that nothing happens to the copper wire. Whereas in case of electrolytic conduction, the flow of electricity takes place by chemical changes at electrode. At anode, oxidation takes place, and at cathode, reduction takes place. If you pass electricity through water, we know that the water will decompose into hydrogen and oxygen at the respective electrode. So water gets decomposed. In case of electronic conduction, the matter does not transfer, whereas in case of electrolytic conduction, the transfer of matter takes place. When you pass electricity through an electrolyte, it first ionizes and the anions move towards the anode, whereas the cations move towards cathode. Therefore, the transfer of matter takes place in the form of ions. Now let us look into the resistance to the flow of current with increase in temperature. In case of metal, when you increase the temperature, the atoms in the metal starts vibrating because of increase in the kinetic energy, and this causes the difficulty in the flow of electrons. As a result, there is resistance to the flow of the current. So as the temperature increases, in case of electronic conduction, the resistance to the flow of current increases. In case of electrolytic conduction, since the electricity is carried by ions, anions and cations, as you increase the temperature, usually the degree of dissociation increases. That is, more numbers of anion and cations are produced, as well as the ionic mobility increases. As a result, the electrolytic conduction increases with increase in temperature. We know that in case of electrolytic conduction, the electricity is carried by ions, whereas in electronic conduction, the electricity is carried by electrons. Now let us understand the terms like resistance and conductance. We know that resistance is the difficulty in the flow of current. It is governed by Ohm's law, that is V is equal to IR, where V is the potential difference, I is the current and R is the resistance. Now, according to Ohm's law, the resistance is equal to the ratio of the applied potential difference to the flow of current. The unit of resistance is ohms. Now conductance. What is conductance? Conductance of a conductor is equal to the reciprocal of resistance, which is given as C is equal to IR, and the unit of C is in mhos or Siemens. Okay. Now let us understand the concept specific resistance or resistivity. Metallic conductor of a uniform cross section having a resistance R. It is directly proportional to length and inversely proportional to area of cross section A. So you can write R is proportional to L by A. Now in case of the solution of electrolytes, the resistance offered by the solution is directly proportional to the distance between the electrode and inversely proportional to the area of cross section. So in this case also, resistance is proportional to L by A. So if you remove the proportionality, we'll get a constant, that is rho, where the rho is known as specific resistance or resistivity. Now you can see that when length is of 1 centimeter and the area of cross section is equal to 1 centimeter square, then rho will become equal to R. Thus, the specific resistance may be defined as the resistance offered by 1 centimeter cube of a conductor. The resistance offered by 1 centimeter cube of a conductor. Now here, the cell constant is L by A. L by A is known as cell constant. It is a fixed quantity for a particular cell and is defined as the distance between the two parallel electrodes of a cell divided by the area of cross section. The unit of rho, that is specific resistance, is ohm centimeter. Now let us understand what is specific conductance, which is denoted by kappa. It is defined as the reciprocal of specific resistance or the conductance offered by 1 centimeter cube of a conductor. Kappa is equal to 1 by rho and its unit is ohm inverse centimeter inverse. In case of metallic conductor, the specific conductance or conductivity is enough to compare the conductivities of two different electrodes. But when it comes into the case of electrolytic conduction, we have to include the concentration of the solution as well. This gives rise to two more conductivities, that is molar conductivity and equivalent conductivity, that we will study in the next session. Okay. This session was a brief introduction to some of the concepts in electrochemistry. There is still to come. This is MCS signing off.